talk about a little bit about what Spring Cloud Stream is. Actually, there's not much to talk about. But anyway, before we begin, my name is Oleg Zhurakousky. I'm a project lead for Spring Cloud Stream and Spring Cloud Function. And so today we're going to talk about what, so in other words, today's presentation is like for those who are users of Spring Cloud Stream, a little recap of how it was, and we're going to talk about what's now and where we're heading with that. For those who are not using, so you will at least learn what it was and the reason why we changed, for example, the biggest change of the programming model. And then we'll talk about what's new stuff. I only have about 6 slides, so then I'll just switch and I'll start coding until I can't code anymore. Yeah, and a little late addition. So my colleague and good friend Chris Bono is going to sort of finish the presentation because he's going to show you something really cool, absolutely related to Spring Cloud Stream, to the new stuff that we're currently working on. So let's begin. Yeah, I told you who I am. By the way, I've been with Spring Source with Spring Organization since 2008. Spring Integration, another project that I was engineer on, Spring AMQP, and every now and then different other projects. So in Spring we kind of like have a single project or 2 projects or 3 projects, but then we're committing pretty much everywhere where the help is needed, or if we want something from somebody, then it's better to do it yourself and then, ask them to just merge the code for you. So, all right. Oh, that's a kind of wrong agenda. So let's Spring Cloud Stream. So Spring Cloud Stream is the framework for streaming, right? So it would be only natural for us to actually define what the stream is, right? So, and again, if you start Googling around, there's going to be, 10 different definitions that you can find. And if I ask you, what is your definition of stream? Probably the same, 10 different people will give me 10 different answers, right? So, so it's very useful for us to define the scope, to provide a definition, because the definition will provide us with the scope. So, and I like the one from the Hazelcast. So, event stream processing is the practice of taking action on a series of data points that originate from a system that continuously creates data. So that effectively means that it's not just me creating some kind of a message handler that will handle the message and that's it, right? We're talking about continuous handling of the messages, continuous handling of the data, events, whatever you want to call that. And so Spring Cloud Stream is a specialized framework to do exactly that, right? So a typical processing pattern for streaming is the source, processor, and sink. So again, this is a very high level pattern because it basically says that there's going to be an origin of data somewhere. At some point of time, the data will originate, whether it's from sensor, whether it's a rest endpoint, whether it's something else, right? And from that point on, the data is going to be streamed through a series of processors, basically the components that will be doing some kind of operations, perform some kind of actions on the data. And at some point of time, that's going to end. That's the sink. So you may want to write it to the database, or you may want to just write something to a log, and maybe you're done with, or send maybe an email message, or literally anything, whatever constitutes for you the definition of done for that particular stream, right? And again, when I say done, it doesn't mean that the stream is over. There could be infinite stream. It could be a continuous stream. So it's the sync part, the done part is done with that block of data or with a particular data point. You're done, but the stream continues. So, and that's what Spring Cloud Stream is for. So, but again, it's a developer framework. So, which means you have to write some code to live within Spring Cloud Stream, right? So before we get into the code part, so again, for those of you who are familiar with Spring Cloud Stream, you know that we have a concept of a binder. So the binder is the essential, the most fundamental component of Spring Cloud Stream. The binder is what binds your code, your piece of code, to a particular message broker. So for example, if you write code, like for example, let's say you have a a system that you have a use case where you're going to get data coming from Kafka, from RabbitMQ, or some other messaging system, and you want, based on each message or based on a block of messages, to invoke this particular method, right? So you're writing a message handler, right? That's your typical messaging app, right? So with Spring Cloud Stream, you do the same thing, except that you are no longer have to worry about all this boilerplate code that has to deal with connecting to the system, establishing connection session, and everything else, because the binder is the component of Spring Cloud Stream that will help you to do that, right? And because Spring Cloud Stream is a Spring Boot-based framework, it means that it comes with predefined default auto configuration. So by simply adding a particular dependency, and you'll see in a minute, by simply adding a particular dependency to your POM, for example, you will be automatically connected to Kafka, Rabbit, or whatever else you choose. So, and once you're connected, whenever the message arrives to a particular destination within that messaging system, the framework will invoke method for you, your code. So, and this is how the code looked before. So we had, as you can see, a lot of annotations. So that you had like a stream listener, which is basically a message handler in a way, and you provide various different destination names. So the sync input, we had source processor sync. They all had default names, but you could define your own destination. So those destinations were bound. They're called bindings. They were bound to a destination on the broker, right? So and that's the connection that was established between the source and the target system of data. The problem with this approach, when I took over the framework in 2017, I didn't like this particular approach because, first of all, I'm not a big fan of runtime annotations because they pollute your code, in my opinion, and they also tie your code to a particular framework. Because if you think about it, when you're writing the code within your message handler, right? That code most likely has nothing to do with streaming, may even have nothing to do with Spring or messaging to begin with, right? So it could be like a POJA code, the function, let's say, that performs, I don't know, debit or credit or something along those lines, right? But because of these annotations, like this is clear that this is not just a Spring Boot app, it's a Spring Cloud Stream Spring Boot app, right? So in other words, if you want to, let's say, part of the functionality to be ported somewhere else, you have to deal with, because now you have to have a compile time dependency to resolve these annotations. You have to do so you have to do a lot of restructuring within your code. So what we decided, and at that point of time, I also took over another project called Spring Cloud Function. And right now, you cannot talk about Spring Cloud Stream without talking Spring Cloud Function. But the idea is that, again, for those who, forgot to mention, for those who did use Spring Cloud Stream before, Spring integration annotations still work, right? But we removed Stream Listener and moved to what I'm about to talk about is functions. So Spring Cloud Function is another framework that I took over, and basically it allows you to develop a code using Java functions. Now, and Java functions, as you can see, clearly maps to this source processor sync model, which is the supplier function and consumer, right? The other benefit of using function, I just told you about the fact that when you're writing the code, it usually is independent from the source or target system, right? But what's also interesting is, if you think about it, if I give you like a question, and it's not a rhetorical question, can you imagine a requirement like from the past or current or in the future that you could not map to either supplier function or consumer? If those were the only three interfaces that you had. Because think about it, we either produce the data, or we receive the data and produce the data, or we receive the data and this is it, right? That's every use case that you'll ever had or will have will always be one of these three. So, and that's really why. So, but if I know that you're dealing with functions, then I can build a framework that allows me to say, listen, with this dependency, I can make your function, turn it into a message handler or a REST endpoint or AWS Lambda or something along those lines, because I can provide a framework that will instrument your function and turn it into something else, right? So in other words, I can connect your function to a messaging system, or I can expose your function as a REST endpoint, and so on and so forth. So that's what Spring Cloud Function does. When we look at it together with the team and with the Spring Cloud Stream and this whole annotation-based programming model, I said, well, what's different? I mean, let's just turn our binder upside down and say, let's bind the code, let's bind the messaging broker to a function the same way we're binding to this add stream listener and so on. So that's what we did, and that's the current programming model. And we had deprecated the stream listener for about 4 years, and finally, with the version of Spring Cloud Stream 4.0, it has been removed. So, but again, for those who are new to Spring Cloud Stream, you don't have to worry about it. That's the only way for you to code. So the good part is that the code now looks like this. As you can see, it's much cleaner. Basically, you have, like, if you look at this application, all that you can say, it's a Spring Boot application, right? Is it streaming, or is it a REST endpoint? Or is it AWS Lambda, or Azure, or whatever? You can't tell. In fact, you can't tell from code. You can only tell from the POM file or Gradle file. You have to look at the dependency to actually see. And this exposes a very interesting point, because you as a developer can develop the code, develop functionality, unit test it, do whatever you need to do, and then the application assembler can say, listen, I'm going to use your function and I'm going to deploy it as part of the Kafka message listener or whatever, so, or REST endpoint or so on and so forth. So you don't have to worry about it, and you can separate your responsibility between functionality and how it's going to be invoked. So, so as I said, tools, we use Spring Boot, Spring Cloud Function, Spring Cloud Stream. So, and this is pretty much done with the slides, so let's start writing the code. So again, for the sake of saving time, I'm going to skip the start.spring.io, but basically you can go on start.spring.io. And you would add dependency, for example. You can say function. You could add dependency stream for Apache Kafka or whatever. So, and then generate the project, and that's what. So, for those of you who you guys are familiar with start.spring.io, right? Yeah. So this is how you generate the project typically, and it just saves you time from. It will ensure that you have the right dependency and so on and so forth. But I already did that. So, right now I'm gonna comment all this. I just again to save time when typing. We'll start from, basically what we're going to do right now is I'm going to show you a few things, but I'm going to start from sort of like a blank sheet of paper, something very simple, and then we're going to expand on it as time permits. Okay, so, all right, so at this point of time, I have a single function called foo, and this function, so this function does nothing, just simply echoes the word. And again, the reason why I'm using the trivial code inside the function is because as a phrase, oh. Yeah. Better, right? Yeah. Sorry, I did not, I just noticed that I'm, So the reason why I'm using the trivial code inside the function is because it's absolutely irrelevant to the framework how complex the code is there. We only care about the signature of the function. Why? Because as you'll see later, we need to, at the startup, introspect the function, get the type information so we can properly do the type conversion and all these other great things, right? So basically, the function definition is important. Function implementation is not important at all, right? So in this case, yeah, I just have a function that accepts string will echo string back. So, and I'm at this point of time, as you notice, I've completely commented everything out from configuration. So this is as vanilla as you can get. So in other words, and the only, like I said, the important part to look at as a POM file. And in the POM file, you can see that I'm using Spring Cloud Stream Binder Rabbit. Obviously, I'm going to be using RabbitMQ. So the Rabbit binder is on my class path, and Rabbit binder, because Stream binder is on the class path, will also pull all the transitive dependency, meaning Spring Cloud Stream core, sprinkle out function, everything is going to end up in my class path right now. So that's it. I'm ready to start. So I'm going to start the application. And it started. And one thing you're going to notice is here's my Rabbit console. It created, it basically, it looked into Rabbit, right? And remember, I didn't have to configure anything at all for Rabbit, just the dependencies. So it connected to default instance on the default port and everything else. It looked inside and says, listen, you don't have the destination that you're looking for, that you're telling us. So we're going to create one for you. So it auto-provisioned destination for me. And destination auto-provision for me, as you can see, is foo in 0. So this brings us to the concept of a binding. So the binding is the mechanism by which we establish a relationship between the actual destination and the abstraction inside of the framework. So we can configure it for various different things. So before, in the stream listener model, we had to explicitly define each binding. Here we decided why should we explicitly define it? We can derive it from the function name. So remember, we had a function name foo. So the binding, it's a function, so it has input and output. So naturally, foo in and foo out, right? The 0 part stands for the index because we also support multiple inputs and multiple outputs, but that's outside of scope of this presentation. So, but what's interesting is that, yeah, okay, so and now if I go back here and I go to foo in and say hello, we can see that the was invoked. So again, I just created a messaging app from literally nothing because if you look at my code, there is nothing messaging related. My POM file has a few things, but I didn't have to do anything else. It just works, right? And now when it comes to the whole concept of microservices, streaming and everything else, now it's interesting to establish the following, is that, right, I'm showing you the very simple function. In reality, it could be something more complex. It could actually be an integration flow internally within this particular microservice, right? But eventually, like when it comes to real apps, what you're actually building is that you probably have several of them. And because they're using the outside destinations, like Kafka topics, so Rabbit queues and exchanges and whatever else, right? It means that you can connect them and establish this cloud-based flow. Now, the benefit of that is that the binders generally talk to a persistent messaging system. And the benefit of that is that, imagine you have something that produces the data, does something, and sends it out to Rabbit, or to, let's say, Kafka topic. And then you have something here, listens to that topic and does something else. And something here listens to the other topic. So now think about the fact that you need to upgrade the application in the middle, the microservice in the middle. Do you need to stop everything? No, because the data will be accumulated, and as soon as the data is persistent, so it's persistent queue, persistent topic. So the minute you restart that service, let's say upgrade or whatever, you start processing the data that was accumulated while you were down. So that provides a very interesting sort of a benefit of structuring the code, structuring your microservices, or architectural benefit by structuring your microservices with a persistent messaging key, destinations in between. Okay, so what else? So now let's say well, I'm checking my phone because I have a little cheat sheet as to what I want to demonstrate to you, because we can do a lot of things. So here's another interesting thing. So because we're using Spring Cloud Functions, so one of my favorite features of Spring Cloud Function is function composition, right? So that's actually a feature of Java functions, right? Not just Spring Cloud Function. However, what we also can do as an additional capability, we can compose the uncomposable, meaning that you can compose functions that may not match the type information. Like, for example, if you have a function that takes string and outputs integer, and you want to compose it with a function that takes string, you cannot do that. Like in pure Java, you'll get a compile error because like you cannot do function and then function this because it's going to say you have incompatible types. However, with our mechanism, internally we're using the same mechanism to compose, but we remove type information because we actually introduced a message converter in between. So every time, so you can compose a function that takes uncompatible type will determine that the types are incompatible, and will basically send it through the message converter that will convert your output type to the input type of the next function. The other when I say compose uncomposable is that you cannot compose function and consumer in the pure Java, but we can have you, we allow you for that, because if you compose function with consumer, what is the end result? Still is a consumer, right? And if you compose supplier and a function, it is still a function, right? So, so in other words, we're allowed to do that, and the way we're allowed to do that is by simply configuration. For example, I can now expose sprinkler function definition, and I'm going to say foo pipe bar, right? And I'm going to go and expose another function called bar here, right? And now, when I actually let me do this. Let me do I should have cleaned the rabbit before, so there's nothing other than the standard stuff. All right, so you see no queues, no changes other than just whatever comes natively with Rabbit. So now I'm going to start the app. And now you have foo bar in, foo bar out, right? So basically, again, we determined from the function name, because the resulting function name is a concatenation of the two name, and we said here's a default binding, right? So now you can see how there's two benefits. So one is that you can say, listen, like Rod once said, there's no such thing as a complex problem, because every complex problem is just a set of array of small problems, right? So you break it down, you address them independently, you test them independently, and then you can just reassemble them at runtime, okay? However, it presents a problem. You know, foo bar, they're three-letter words, they're simple, right? But real functions could be more lengthy, and when you compose them, you're going to have the binding name this size. How do you go about this? Because it's really difficult to not make a typo and then spend like hours to figure out what's wrong, and then actually you made a typo, right? So what we can do is, this is where, like, again, Spring Boot gives you, like, and Spring Cloud Stream under boot gives you out of the box, sensible set of defaults. But now we're going to introduce some additional configuration that will allow us to simplify our life, right? In this case, what I want to do is say, listen, I'm glad that I know about this binding name convention, but this name is not good for me. I want to, because on top of this binding name, I can provide another 10, 20 configurations. And I don't want to use this foo bar in 0, whatever, because it's very confusing, right? I want to convert it to something, or map it to something more logical. So, and what we have is Spring Cloud Stream function bindings, foo bar in 0. I can map it to the word input, right? So now look what's going to happen. I'm going to clean again, and I'm going to look at what's going to happen when we restart the app. And again, you can see I'm using it it's demo friendly to do auto provisioning. In a real life, that rarely happens. When you're writing stream apps, you already have some destinations established. So, like I said, if the destination is there, it will connect to it. If it's not, it will attempt to create one. All right, we're good. So let's start again. So now, instead of foo bar in, we have input, right? But we have foo bar out, because I did not map the foo bar out, but I mapped foo bar in. So you can see how easy I can do, because now what I can do is I can actually do spring.cloud.function.input. No. Stream So what I'm doing here is, if I did not do the mapping of the input, that line 5 would read spring.cloud.stream.bindings.foobar in0.destination, right? So what I was saying earlier is that we have a lot of different configurations that you can do on a binding, to configure a binding, and you would have to use that name all the time, right? So it's only natural and useful to convert it to something more useful and more readable. So that's what I effectively did, right? And what I did with this configuration is to what I was telling you earlier, is that if I have an existing destination and I want to bind to that destination, then I'm basically saying now not only that I mapped foobar into input, I'm also mapping input to a destination called Oleg, which means like it's going to be Kafka topic or Rabbit Exchange or so on and so forth. Okay? All right. By the way, if you have any questions, ask them right away. I don't like to wait till the end. I'd rather answer them in context. So, okay. Another interesting topic is that came new is that we didn't have in the Spring Cloud stream with the stream listener is like, right now I'm dealing with the simple strings, right? So if I create a POJO, it will convert it to using whatever converter. We have 3 on the class path, the primary one is the JSON one, so if you're sending a JSON input, it will convert it to that particular POJO with no problem, and I can show it to you. But what I really want to show you is different right now, is that sometimes, like right now, with the strings, I'm showing you the actual payload as a very payload in the string, payload of the data coming in the string format, right? But the data coming in, there's much more data that's coming in. So there's, for example, if you look at the concept of a message, it contains both the payload and the headers, right? So actually, a lot of times you actually do need to have access to these headers, right? So what you can do is, so now if I start the app, you can see that I received the entire message, okay? So now I can look at all the headers and everything else, right? So, but again, what we like to do, as you can see for now, this app outside of Spring Boot annotations like Spring Boot application and add bean had no dependency on anything Spring, right? And it's not that I advise you to not use Spring, it's the opposite. It's like, yes, do use Spring, but I also want to give you option to only use Spring when you absolutely need to, right? And by putting a message into the function definition, I immediately tied you to Spring messaging, even though it's internal detail, okay? So what can you do to stay clean? All right, see what happened? So I used, we support by function. That's a new feature of Spring Cloud Function, specifically made for, primarily for Spring Cloud Stream. So what happens here, so there's one interesting nuance there that you have to be aware of that. The signature must be POJO, which basically could be any object, right? Could be anything. But the second argument must be map. Because we're not, in other words, by function for us means that you actually want to receive payload and headers. And that's the declaration, that you want to receive payload and headers. And we're going to map them as such. So it's not just a function, because otherwise you're giving us a request to give me 2 inputs, and I don't know which ones you want. So I have to only, so right now we only support this, so because there's no default convention what it could be, right? And so yeah, so right now, again, the same function, so nothing should change from invocation perspective. So I'm just going to go back there, and I got everything that I wanted to. So but now I have separately. Well, I'm displaying just the payload, right? But oh, yeah. I was wondering why. Oh, and by the way, look what happened. I'm composing in a way here, composing the uncomposable. So I'm doing foo bar. Well, actually, this is composable. Well, no, it's uncomposable because bar receives message string, right? And foo outputs string. See it? So because my function is foo bar, right? That's a composition. And I can do the opposite because I can compose the bar foo, for example, and that's even more uncomposable because it's a function with bifunction and it still will work. Okay? How are we doing with time? 17? Oh, okay. So another new thing that we did, again, we had like a very elaborate exposure to internals of the framework when it came to the old Spring Cloud Stream model with the stream listener, because like if you want to do, let's say, error handling, we said, oh, now you can send to this channel. You had to know a lot because Spring Cloud Stream is based on another framework. It's like a layer on top of Spring Integration, which is the enterprise integration pattern framework with the concept of channels and everything else. So like we had to expose all that to the end user. So the user, when configuring all these annotations, had to know also a lot about the framework. So again, with functional model, we attempted to drop that requirement and just to keep you as light as possible. So, but again, we also wanted to make sure that regardless of what we do, if you're existing user, we want to provide complete alternative to what you had with the stream listener, and we finally did that, right? So, and one of the big efforts for us was to error handling mechanism, right? Because error handling before was based on you knowing the schematics of how to name your channel and then adding this channel as a service activator to your error handler. Right now, it's much simpler. Again, you don't have to know about the channels. You just simply create a consumer, call it whatever it is you want, and this consumer, let's say, so again, going back to the error handling, I'm only showing you the new features because when it comes to messaging system, the DLQ and all other things, the system-based error handling, it's all there. That didn't change, so everything works as before, right? But the new stuff is the functional-based error handling. Like when you want to do something on your own, let's say you wanted to manually send it to DLQ, or you want to send an event or something along those lines, notification. So you simply define a consumer type bean. You can define it as a function, just that output will go absolutely nowhere. But the consumer type bean that will receive an error message, okay? And now in the configuration, all you need to do is to say that my Spring Cloud stream let me just copy. Yeah. Thanks for noticing. So I called my error handler or my consumer handle. So basically, naturally, I'm saying for this binding, if error happens, call this handler, right? So I'm going to start it. Go back in here, say hello. Everything works as expected, but now, as you can see, I have that if statement there saying if I send the word error, it will do the... All right, let's review what happened here, actually. So this is another feature, again, that always existed, but again, for those who didn't use, so you can see 3 times error, because what it did, it attempted to retry. Once, twice, on the 3rd time, it failed. And again, retries are configurable, so you can configure, there's many different configuration properties you can have, and if everything fails, you can write your own implementation of a retry template, right? But the bottom line here is that it tried and it failed, and it basically routed to the message to my handler. Last thing before I turn table 2. So speaking of routing, is that so we right now to show you how it routes to the error handler. But what if you want to do internal routing to different various different functions? Because, for example, you may not want to expose all these functions to as a bindings, right? You may want to just have like a single function and then route internally because it's safer, it's easier to maintain, and you don't have to maintain many endpoints, right? So what you do is very simple. So you can say, again, there's many different ways you can do that. So, but I can simply say, let me comment all this stuff out, and by simply saying I want to, by using one of the properties of related to routing, you're effectively enabling routing. So the cleanest way would be to say Spring Cloud function definition router function, but that means you have to know the name of the routing function because it's always there for you, it's provided by the framework. But in this case, by simply saying, I'm defining routing expression, I'm simply saying, when the message arrives to routing function will look at the headers, and whatever the value is in the header foo is gonna use that as a function name to route to. So, and this way you don't have to know about the name of the routing functions and everything, you just, by simply enabling the property, you enabled this, right? So now I'm gonna start the application again. And we go back to Rabbit, and we see the function router in, right? So now I can go here, say hello, and was it foo? And I'm going to say bar, right? And now we simply route. In other words, the only function that is exposed is the router function, and now I can, based on the header, based on the expression, or if your routing logic is very complex, you can write message routing callback. So there's all these different features available to you, and they're nicely documented. All right, I could continue for another hour with all these different things and whatever. I attempted to cover the most important that I believe, but I'll be available here for any kind of questions. But at this point of time, we also have another new things that I cannot miss to present, but I'm not going to do it. Chris Bono is going to do it, my colleague and friend.
Cool. All right.
Any questions, guys, while Chris is setting up?
So for error handling, you mentioned a class called error message. Is it really a type or?
Yeah, it's a type that comes from Spring messaging. Again, and you don't have to. Let's say if you don't want to tie yourself to it, you can go back to a message because it's a subclass of message, or you can go back to object and then doing it reflection based. If you don't want to tie yourself, if you don't want to make a code as a binary dependency of Spring, for example. So, yeah. So any other questions? You ready?
Yep.
All right.
Cool. So if y'all can't hear me, let me know. There's only one microphone. So what we're going to show is the Apache Pulsar binder for Spring Cloud Stream. So Oleg talked about the Rabbit binder and the Kafka binder. And so Pulsar binder is the newest binder we have. And so if you're not familiar with what Apache Pulsar is, it's an open source distributed and streaming platform, messaging and streaming platform. It's highly performant. You can scale up to a million topics. You get the best of both worlds. Like if you're coming from a Rabbit environment, you're used to single messaging, and from Kafka, you're more of a pub/sub streaming platform. You can Pulsar has a subscription model that's flexible, so that you can configure your topics and your subscription to act as either one of those. You can make it look like Rabbit or look like Kafka. Let's see. It's popular. That's donated from Yahoo to the open source project in 2018. It's already got 12,000 GitHub stars, and there's like 70 active contributors. And what is Spring for Pulsar? So what we did was we did the same thing that we've done for Spring Kafka and Spring Rabbit for Pulsar. We have a Spring Pulsar offering now, and it brings Pulsar into that Spring messaging ecosystem. At a high level, this goes over the architecture of those flexible subscriptions I was talking about. There's exclusive, there's shared, and failover. I'm not going to get into the details of them. We're limited on time, but that's one of the key strengths of Pulsar is this model. And at a high level, this is the architecture of where Spring Pulsar sits on top of that. Pulsar exposes itself to external world through client APIs. Specifically, there's 5 languages that they have APIs for, or client implementations. We are interested in the Java one currently today. And there's a reactive client and an imperative client. And on Spring Pulsar, we have one of each. There's a client for both reactive, or there's a set of producers and consumers for each imperative and reactive. And so here's what we're going to do is I'm going to take this application that's doing user registration. Well, this is not a Spring Cloud Stream. This is just a straight Spring Pulsar app, and this is in a continuation. All we're doing is taking users and we're sourcing them into a Pulsar topic, and then we're reading from that Pulsar topic, produce and consume. And then what we're going to do is show how easy it is to hook a binder, a Spring Cloud Stream into the mix. And so let me run the app. What was that? Oh. Oh, got it. Produce, consume, produce, consume. Okay, so what's happened here is that we're just producing. Let me see what happened. What's that? Oh, it's still a registered user. Yeah, okay. I went backwards from the demo earlier. Bear with me. Christoph was there doing the demo with me, so luckily he remembers what I didn't do. So here we are producing, consuming users to and from a topic. And so let's say that we wanted to do something a little more interesting there, like do something with the user object. And Oleg was just talking about Java functions, right? Let's don't talk about Pulsar for a minute. And let's say, suppose I have a function that takes a user and turns it into a registered user, right? I'll call it something like this.
Yeah, in this case, you'll see a poser function too.
Registered. You'll see a what?
Poser function. Like
yeah,
the function
poser
that
function.
takes the,
exactly.
something other than string.
Yeah. User. Okay, we're going to take that input user,
Yeah.
and we're going to return a new registered user that takes in that user and does a tier.values. Let me do some other bad demo practices here. Don't do this at home. Values. And we'll do tier dot, and we'll do rand. And then we'll do tier dot values dot length. We'll do that. All right. And then we'll fix this a little bit. Okay. Okay, so now that we have a Pojo function that's going to take a user and create a registered user out of it, what do we do with that? So we want that first input parameter to come from a user topic, and then we want to spit that out to a registered user topic. And so Spring Cloud Stream would be a great mix for this, or a great fit. So let's do that. So if we jump over here to the YAML, what was it? Spring Cloud function definition is what we talked about a minute ago.
Yeah.
And that will be the name of our function, register user, right? And stream bindings, Spring Cloud stream bindings. And we know that it is the name of the function, register user, input parameter 1. Its destination will be user topic. That's where it's coming from. We also know that this consumer, I'm going to tell it some other information. Use native decoding. This says, let's don't use the encoding that Spring Messaging is using. Let's use Pulsar's native decoding. Likewise, register user output parameter, that second parameter. Let's send it to the reg user topic, right? And I also know that its producer needs to know a little more information. Use native encoding true. We're almost done. We have one more thing. So there's technology-specific binder settings sometimes. In this case, Spring Cloud Stream Pulsar bindings. In the current incantation of our binder, we need to tell it a little bit more information. We're working on getting this so we can inspect it at runtime. But let's say we also need to say register user. That same input parameter, I'm going to tell Pulsar, because we're using that native encoding decoding, I need to tell it a little something more.
By the way, while he's typing, the native encoding decoding, so like I said, we have internal, within Spring Cloud Stream, we have type conversion framework built in.
Yep.
But sometimes, especially in the cases with Kafka and now Pulsar, users prefer to use native type conversion, and that's the flag that says, don't use Spring Cloud Stream type conversion, fall back on whatever Kafka, or well, in this case, Pulsar provides you.
So this last part looked a little daunting, but all we're saying is, hey, for that input parameter 1, it's of this type. For the output parameter, it's a registered user. And now if we come back here to the Pulsar application, you can see this is that in 0, and this is that out 0. And I have let's do one more thing here. Let's change our reactive Pulsar listeners such that, this is how it was before when it failed. So let's change this to registered user, okay? Registered user. Okay, slow down. Registered user, okay. So I have a theory here now that, so this first function up here, I was sourcing, not using Spring Cloud Stream, just using the Pulsar template to that user topic. Then we just wired up something that's going to read from that input topic, turn it into an registered user, and then spit it back out to a registered user topic. So let's push the play button. Oh, yeah. That will not work. That's the same. What am I gonna do whenever you go back home, Christoph? It's gonna be bad. Okay. Topics equals reg user topic. All right, cool. There we go. Free enterprise. You can see the difference is this little free enterprise thing hanging off the side. And so, yeah, that's it. We took Spring Cloud Stream, we wired up the Pulsar binder, and we've combined a Spring Cloud Stream and just a regular Spring Pulsar application. And that's basically all I have on that. Well, how much time do we have left?
We have no time left, so it's perfect.
Perfect.
Yeah.
Let's talk.
We have 1 minute left. 50 minutes.
45, right? Yeah.
Well, no, 45 is the next presentation.
We have time to talk, right?
We have to talk, yeah, we have time to talk.
Yeah.
So guys, any questions? All right, where are we taking it into the future? So a lot of the future thing right now consists of cleaning up the code from within the Spring Cloud Stream core, because if with switching to Spring Cloud Function as a programming model, we effectively, because with the stream listener, the type conversion, all that other stuff, everything was happening in the Spring Cloud Stream. So it was a really rich framework. Right now, we moved everything to function because I want to write a single function and I want all the features, whether it's a streaming function or whether it's a REST endpoint or whether it's whatever, no matter how instrumented. So all this thing is happening right now on a function level, which means that Spring Cloud Stream is becoming slimmer and slimmer and slimmer. So we're actually in a big sort of a code cleanup thing, because right now, if I were to define what is Spring Cloud Stream right now, it's a binding framework. But because it uses Spring Cloud function, it gives you all that other stuff. But so in other words, you have to almost look at it as two things. Otherwise, just Spring Cloud Stream, it's just a framework that binds a broker destination to a piece of code, right? So the more binders. That's another. In other words, it's gaining popularity. So we have a Kafka Rabbit. So Chris just showed you the Pulsar. We also have a community binders like Solus and Kinesis and so on. So what else? We're trying to. There's a couple of experimental branches where we're trying to. All these binders are based on. We haven't talked about this because. A matter of separate discussion, but consumer groups and partitions, right? So all those binders based on the concept of consumer groups and partition, as well as persistent store, what I was telling you earlier. So I can, for example, when I'm building the topology, I can stop the processor while my source is still producing data and without any worries, right? However, what we're also trying to do is say, listen, should we actually, because originally that was the requirement, that if the binder is something that complies with the concept of a persistent store and supports consumer groups and partitions. But we're now reevaluating whether it's necessary to be as a requirement, because we could have a binder say, listen, this binder doesn't support these features, but it will allow you to connect to a different system. For example, you want to expose the left side of the function as HTTP REST endpoint, and the right side of the function go to Rabbit, right? So you can do it right now. We have a component called Stream Bridge, right? Specifically designed to bridge none, but at this point of time, you coupling yourself to something within Spring Cloud Stream, you have to inject it or wire it, whatever, and then send it to a particular destination, right? So you have to do a little bit of a boilerplate code, even though it's like a one line of code. But if let's say we had let's say HTTP binder, then I would not have to use Stream Bridge, because I would simply say it's a case of like we support multi-binder scenario. Like right now we support, let's say, go from Kafka to Rabbit, right? Or go from one Kafka instance to another Kafka instance. So in this case, I would go from HTTP into Kafka, into Pulsar, into whatever. So that's actually the big thing, because we wanted to, because since Spring Cloud Stream became a binding framework, now we want to be able to expand the concept of binders into pretty much anything. So.
Yeah, look right here. This is what you're thinking of.
All right, guys. Thank you so much.